It's like my dinging. Unit 1. So, Unit 1 was set theory. We're going to probably do all of our set theory, all of our Venn diagrams, up until probably about probability. And then we'll do that second half tomorrow. So we should be done this review. So Wednesday, Thursday, we'll do practice days. Friday will be test day. Set theory. There was a bunch of definitions that we learned right at the beginning. Those definitions and symbols became very important to us because most of the questions were just symbols, right? You got to kind of remember that weirdness. The first thing we learned was something called a universal set. Universal set. The universal set is like everything that you're considering in a question. So if I'm talking about everyone in this room, we would be the universal set. It's everything that I'm considering. Usually a question defines your universal set right off the bat. They're like, this is the universal set. Sometimes they do like the letter U to symbolize it, but I wouldn't worry too much about that. You just need to know universal set means everything. Within a universal set, you have something called subsets. Subsets are like groups within the group. So the universal set is us as a group, everyone in this class. A subset is a group within our group. So for instance, if you're somebody who plays, I don't know, hockey. So if you play hockey, anyone in this room play hockey? I just picked a random sport. Hey, good. You would be in that subgroup or subset of people. We'd say you're the group of people who play hockey. And you're inside of this universal set, the big group. To use a symbol for subset is this right here. That means subset of. The way we see it written most often is like this. That means A is a subset of B. So everything in A is a group inside of B. And A is a subset of B. All the things in A are in B. Again, we're thinking of it like us. So if all of us in this room is group B, people who play hockey in this room is a group inside of the group. An empty set. An empty set is a set with nothing in it. So like there's nothing there. For instance, people in this class who are in, there's a class that none of us were in. Is it Physics 30? Art? Was it art? Anybody in this class in art right now? Ah, there you go, right? So there's no one in this class that's in art class. So that means we have an empty set within this group. It's the people who are taking art right now. We recommend. We represent an empty set with this symbol right here. It's like a 0 with a line through it. That means empty set. So we'd say A is empty. That means group A is an empty set. There's nothing in that group. Complement of a set. We've done lots of things with complement. What does the word complement mean? Yeah. Somebody whispered it over there. It means opposite. Most often we use the word not to describe opposite, right? So the complement of a set is people who are not in something. So if I had our people who play hockey in here, the complement of playing hockey would be not playing hockey. It's the complete opposite. It's not something else. I'm not like, okay, you have people who are playing hockey and you have people who are playing soccer. Those aren't complements. They're different things. Complement is by using the word not. It's the complete opposite of something. We recommend again. We represent it with an apostrophe, right? So it looks like this. A with an apostrophe. That means it's not in set A. Sometimes you might hear somebody call it A prime. I've never used that terminology, but just in case. Feel like we remember these definitions? I see a lot of nodding, which is a good sign. All right. Probably the two most important ones are the intersection of sets and the union of sets. That's what we saw the most of. We'll start with intersection. The intersection of a set is like if you're in both. We use the word and to describe it. I'm also going to put both because I'm noticing that that word comes up a lot too. So that would be like if you are in English and in social, right? That would be you're in both things. I know there is a group of us that are in English and in social. I don't know if there's anyone left over in this room. Are you in English social? Yeah, I was like, there's a couple. Anyone else English social? 1, 2, 3. We got 3 people who are in English and in social. Using symbols to represent that, we would write it like this. So if A meant English and B meant social, that would say you're in English and in social. You're in both. The other one was, the other one was the word or, which was the union of sets. So that means you might be in both, or you could be in just one of them, or you could be in the other. So if I ask you, are you in English and social, versus are you in English or social is very different, right? So if in this class, we had our 3 people who are English and social. Is there anyone who's in English or in social studies? Yeah, like put your hand up so if you're in English or in social so I can see if there's a very few of you guys. You guys did well avoiding English and social this semester. So there's 1, 2, 3 more that we would add to that group, right? You have either English class or you have social class or you have both, which is our original 3 people, right? It's like adding everything together. Our symbol for or was this like U looking symbol. That would mean you're in group A or B. Awesome. Disjoint sets. Disjoint sets sometimes get confused with complements. Disjoint sets are things that don't share anything. It doesn't necessarily mean they're opposite. Okay, it just means they don't share anything. So if I'm talking about people who play hockey in the classroom and people who play football in the classroom, there's nobody that does both in our class. You're not complements of each other. A complement would be not playing hockey. Disjoint is if you don't share. Nobody does both. That's called disjoint. Disjoint right here. 2 sets have no elements in common. Nothing in both. I think that was it for definitions. Just kind of ripped through all of them there. Cool. Let's do a question. So we've got some sets here. They should have given us the universal set, which they didn't, so I'm going to write it at the top. Universal equals numbers less than 10. My writing is very messy today. Hand doesn't want to work. All right, looking at that question. It says, consider the following sets. Universal is numbers less than 10. Group A or set A is natural numbers less than 10 that are divisible by 2. Set B is natural numbers less than 10 that are divisible by 5. And set C is natural numbers less than 10 that are divisible by 6. I find it easier for these types of questions to write out what those numbers actually are instead of just trying to remember them. So when it says that A is natural numbers less than 10 that are divisible by 2, I'm just going to list out what those numbers are. So for instance, like the number 2 is divisible by 2. Number 4, number 6, number 8. And we're going to pretend it said inclusive, so we're going to include the number 10 as well. It would have said if 10 was included or not on a test, just to make it clear. And if you're ever wondering if you're like, hey, is 10 part of this? Ask. I can probably help you with that. Question B, group B. Natural numbers less than 10 that are divisible by 5. I find it easier to list them. So that's the number 5, the number 10. And our last group is C, natural numbers less than 10 that are divisible by 6. That would be just the number 6. So only number divisible by 6 is 6. Awesome. List the elements in the following sets. First one, A, then that symbol, then B. If you were to read that, you would read in set A and set B. Remember, and means both, so you have to be in both groups. So what numbers are in both groups? A and B. Well, let's look at group A. We got 2, 4, 6, 8, 10. Group B, we have 5 and 10. The only number that's in both is 10. That's it. That would be group A and B. The second one, if you read it, is A or B. So it reads in set A or set B. This is like adding groups together, right? Or is like adding everything together. So when I'm saying what numbers are in A or in B, I'm just going to essentially add the two groups together. So the number 2 was in one of the groups. The number 4 was in one of the groups. The number 5 was in the second group. 6 was in the first. 8 was in the first. And 10 was in both. So the things that are in A or B, all of these numbers are in A or in B or in both. Awesome. Third one. This symbol is key. That means not in A and in B. So you're looking for numbers that are not in A and they're in B. So for instance, the number 1. The number 1 is not in group A. The number 1 also is not in B, so I wouldn't include it, right? The only number that's not in A that is in B would be the number 5. That is not in A and in B. Feels okay? Yeah. Remember, there's a lot of test questions that are just like this. It's just the symbols, right? And people are like, whoa, I don't remember any of those symbols. And then you would think I'm crazy on the test. You're like, that doesn't even say anything. It's like, oh, it does say something. right? Just got to remember those symbols. It becomes key. As I lecture you about symbols, there's another symbol that we always forget. Let's see if it doesn't pop up. Okay, I'm going to write it. We have a little spot for definition here. There's one more symbol. I'm going to go up a slide. I'm going to add it. It's the symbol N. Because we see that a lot. It means the number of things. Example, something like that. N, A, and B means the number of things in A and B. Sorry, I forgot that. To put that on the list. That's probably an important one. That's what pops up on a test too, right? They put N of A, and you have to be like, okay, what is the number of things in A? Let's look back at our set theory question. So they add another group here. So they've got list the elements for the following sets. If D is odd natural numbers less than 10, again, I like to go and write that out. So D, that means is 1, 3, 5, 7, 9. Odd numbers less than 10. Perfect. Now we've got these bigger questions. I like to do the brackets first and then outside the brackets. It kind of helps me like break things down. So if you look at question I, the first one here, it says in A and in B or D. If I break it down and just do the brackets first, I'm like, okay, well, what is in B or D? I'm going to list out just those things. So the numbers that are in B or in D. B was 5 and 10. D was all these things. So the numbers that are in B or in D would be 1, 3, 5, 7, 9, and 10. Those are the numbers that are in B or in D. I'm only doing the brackets here. Then I can do the other part of this question. The other part of this question is you're in A and that group that we just created. So what number is in A and in this group that we just created? There's only one. So like looking all the way back up here at group A, the number 2 is in A, but it's not in this new group that I made. The number 4 is in A, but it's not in this new group. The only number that's in A and in that new group I made was the number 10. The number 10 is in group A, and it's in that group that I made in the brackets. All right, let's try the same thing for number 2. Number 2, if we did in the brackets first. In the brackets is the list of things that are in A and in B. We know the only number that's in A and in B is the number 10. Then we can do the second part of this question. It's or in D. So now I've got this little group, 10. So I'm looking for numbers that are in this group or in D. Or is like adding groups together. So I'm going to take group D and I'm going to add it together with this new group that I made in my brackets. That means that the total number of things in A and B or in D would be 1, 3, 5, 7, 9, and 10. That's all the things in D, all the things in A and B. I'll give you a minute on that one because that one's confusing. So think about it. Ask, be like, why is this number in there? Why isn't this number in there? Why is there so many numbers in there? All right. The third one. The third one is asking me to not be in a group. I find it easier to do in the brackets first, then do outside the brackets. So if I focus just on this, I want to list all the things that are in A or in B. The numbers that are in A or in B would be 2, 4, 5, 6, 8, 10. Those are the numbers that are in A or B. Now I want the numbers that are not in that group, right? This means not. It's the complement. So the number of numbers, the numbers that are not in that group, you want to go all the way back to your universal and ask yourself the numbers that are not in that group. The universal was numbers less than 10. So the number 1 is not in that group. Number 3 is not in that group. 5 is in that group. The number 7 is not in that group. The number 9 is not in that group. Those are the only numbers that are not in this set of numbers. Set theory? Yay, nay, middle ground. Monday blues? All right, let's keep it rolling then. Venn diagrams. You guys were crushing Venn diagrams by the end of Venn diagrams. So I'm a little excited to see how you guys do on the midterm with your Venn diagram questions. There'll definitely be some on there, just so you're aware. A Venn diagram is just a way to represent what's going on. Right? We represented it like this. It was a big box. That big box represented the universal set. That meant everything we were considering was going to be in that box. It's like this room, right? This is our universal set in this classroom right now. Inside that classroom or inside that universal set, you have smaller groups. In this case, we have 2 groups. We have group A and we have group B. We represent them with circles. A is going to be one circle. B is going to be another circle. You'll notice that there's some overlap of the 2 circles. That overlap is where you put things that are in both groups. So if we think about this, we got our set A up there at the top. The number 2 needs to be in circle A. So I put it in circle A right there. The number 4 needs to be in circle A. So I add it to circle A right there. 6, 8, and then the number 10, if we look, is in both groups. instead of writing it twice and putting it in circle A and in circle B, we put it in the middle on that intersection point. It goes right there. That shows me that the number 10 is in both groups. What time is it? 10:40. We're trying to track when the internet starts to go bad. It is going bad at 10:40. The next number, the number 12, is only in A. 14, 16, 18, and the number 20 is in both. So it's in that little intersection spot. When we look at the rest of the numbers, we got the number 5. The number 5 is only in B. The number 15 is only in B. We feel like we remember that, Venn diagrams, yeah? So if I'm like, hey, what numbers are in group B? The number 5 is in group B, 15 is in group B, 10 is in group B, and 20 is in group B. They're all in circle B. If I said which certain numbers are only in circle B, it'd be these two, 5 and 15. Oh. Awesome. There's one more section to a Venn diagram that we haven't filled in yet. And it's a universal set. So it's the numbers on the outside of the circle. They never told us what the universal set was. We're going to assume it's from the same question before, where it's like numbers less than 10. We're going to say this one's numbers less than 20. So we would write those things on the outside. For instance, like the number 1 is not in either circle. 3, 7, 9, 11, 13, 17, and 19. Those are the numbers that are not in either circle. That's a Venn diagram. It's just a nice way to organize things. There's some pictures of some Venn diagrams here. We're going to try to answer set theory questions about these Venn diagrams. So for each example, describe, represent the word set in words. That's not a good sentence. Describe the set in words. I don't know why the word represent is there. Shade the region of the Venn diagram and list the members of the set. Okay. The first one. If you were to read this, this reads in A and in B. A quick look at our Venn diagram. I'm looking for the number 15. That is the only number that's in A and in B. If you were to shade it, that means you would be shading this section of the Venn diagram. It doesn't mean that I'm shading A and B. I'm not shading all of A, all of B. I'm shading the only section that's both A and B. Number 2, if you were to read that, that reads not in A and not in B. So I'm looking for a section on this Venn diagram that's not in A and not in B. If you think about that, that's going to be all of our outside section, right? That's the only area that's not in A and not in B. If we were to list those numbers, 1, 2, 4, 7, 8, 11, 13, 14, 16, 17, and 19. Those are all the numbers on that outside section. They're not in A and they're not in B. If we were shading a Venn diagram, that means I would shade all this outside. I'm trying to shade it without covering the numbers. It would look something like that. I'm sure you can shade nicely. Awesome. Number 3 is the hardest one. Remember that you want to do in the brackets first, then outside the brackets. So if you think about what inside the brackets is, inside the brackets is A and B. That's only the number 15 right here. That's A and B. But they're asking for not that. So everything except A and B. That means we're looking for all the numbers on the outside. We're also looking at all the numbers that are only in B and the numbers that are only in A. The only section that's not shaded is the very middle part. If you were to list your numbers, that means you're listing all the numbers from 1 to 19, except for the number 15. So it's going to be a long list. It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 16, 17, 18, 19. Those are all the numbers that are not in the middle. Every number but 15, right? 15 is the only one that is in the middle. So I listed everything but 15. That's bad. All right. More Venn diagrams. For fun, let's just try all 3. Okay, so go ahead, see if you can write what it means in words. Actually, words is pretty hard with that one, but try if you want. But definitely shade it and definitely list out what's in each group. I'll give you a couple minutes to try so you can see if you're getting it right or wrong. So if you were to read that first one, that's A or B, right? So you're listing all the things that are in circle A or in circle B or in both. It's like adding the 2 circles together. If you were to color it, you're coloring like the entire, actually, I'm going to list it first, and I'm just going to color right over it. So it'd be 3, 5, 6, 9, 10, 12, 15, 18. Those are all the numbers that could be found in either of these circles. So if you were to shade it, it would look like that. Notice that I did shade the middle. For whatever reason, sometimes people just don't shade the middle because they're like, and is the outsides? No, it's both circles, everything shaded. Perfect. Now it starts to get a little more interesting. Number 2 is A or not B. Or is like bringing everything together. It's like adding the groups together. So when I'm shading, I want to shade all of circle A or any section that's not B. This means I'm shading in all of A, including the number 15. That's the spot people don't shade. They leave this part out because they said, well, it says not B. It does say not B, but or is like adding things together, and this section is part of A. So I circle all of A, or now go shade anything else that's not in B, which would be the entire outside section. So all this stuff. The number 15 is the thing people miss. They don't shade that because it says not B, and that throws people off. Remember, or, shade all of one, shade all of the other. If you were to list it, the list is very long. It'd be 1, 2, 3, 4, not 5, 6, 7, 8, 9, not 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. Last one. We look at the inside. The inside would tell me to shade anything that's A or B. That would be all of this. If we were only doing the inside, right? But then the outside has this apostrophe, which means you want to not shade that section. You want to shade anything else but that section. So when you're thinking about this, that means we're talking about the outside, like this. You're circling or shading anything but what's in those two circles. If you're to list it, I'm not going to write it out. It'd be 1, 2, 4, 7, 8, 11, 13, 14, 16, 17, 19. All those random numbers that are not in those two bubbles. That's Venn diagrams. Honestly, what we use Venn diagrams for the most, besides like sorting information, is for surveys. Right, so we did a lot of these type of questions where I was like, oh, so-and-so did a survey about if you do yoga or eat out for lunch, right? And then it was like numbers inside of the bubbles, which represented how many people were in that section. So for this question, we have two groups. We have S. S is the number of kids who eat suckers. Anyone in this circle S eats suckers. Y is the number of kids who like yellow. That means anyone in this circle likes the color yellow. I know, but the yellow doesn't look good. It kind of upset me when I was doing it. I literally thought the exact same thing. I'm like, should I really be using red to represent kids who like yellow? The yellow just doesn't show up nicely. Should I switch it? Okay, I feel that. I feel that pain. That's a real struggle. Yellow. Oh yeah, I see what you mean. Especially with the blurriness that's on our TV screen, it probably doesn't help. The blurriness doesn't help. It's an internet connection, so like you're trying to get from my computer to the TVs. Too much internet power, I suppose. What do these numbers mean? Okay, so if I'm just looking at the Venn diagram, I'm not going to answer the questions. Just the Venn diagram. The number 12 here What's different between 12 and 3? They're both in the blue circle, but why did they separate it out like that? These 12 people like suckers, but they don't like the color yellow. That's why they're separated. The 3 people in the middle like suckers and like the color yellow. That's why they're separated into the middle. And the number 7 represents, I think it's a 7, so blurry I can't tell. The number 7 represents people who like the color yellow, so they're in the yellow circle, but they don't like suckers. I don't know who doesn't like suckers. If you don't like suckers, you're going to be crazy. There's got to be a sucker out there that you can like. So that's 12, 3, 7. Now let's answer some questions. So for A, how many kids eat suckers? This is like asking this on a test. How many kids like suckers? Using set theory notation, N of S. That means the number of people who like suckers. Same thing, but now with symbols. For us, the number of people who like suckers would be 12 plus 3. The difference is 12 of them like only suckers, 3 of them like suckers and the color yellow. But both groups still like suckers. So the total number of people who like suckers is 15. Question B. How many kids like the color yellow? That would be like saying N bracket Y. I'm doing it in yellow because, just like to stay united with the yellow theme. That says N bracket Y bracket. So N bracket Y bracket. The fuzziness in the yellow make it even worse. The number of people who like yellow would be 3 plus 7. Right? These 3 people like yellow. These 7 people like yellow. 3 plus 7 is 10. There's 10 people who like the color yellow. And now I'm done using that color because that's brutal. C. How many kids like yellow but don't like suckers? If we were to talk about this with set theory notation, that's the number of kids, so N, who like yellow, so Y, but don't like suckers is kind of like saying and don't like suckers. So using set theory notation, N means the number of people or number of things. The number of people that like yellow, so Y, and or but don't like suckers, S with an apostrophe. For us, that's only these 7 people out here. These 7 people like the color yellow and do not like suckers. Our last one, D. How many students like suckers and yellow? If you were to write this out with set theory notation, it'd be N bracket, suckers is S, and Y for yellow. Remember, that's how a lot of test questions came up. They gave you this information, and then instead of saying this, they just gave you the symbols. And you had to know what that meant. The number of people who are in group S and Y, like suckers and like yellow. There is 3 people in that group. 3 people like suckers and the color yellow. Whew. Creating a Venn diagram. I'll leave the triple ones for, we'll see. In a survey of 400 people, it was found that 285 enjoy pizza, P, and 320 enjoy muffins, M. As well, 63 people do not enjoy pizza or muffins. How many people like pizza and muffins? Accurately fill in the Venn diagram to show this situation. We're going to do the Venn diagram first. If I could reverse that question, I would, because then you can easily use the Venn diagram to answer any questions they might have. So let's start off with creating the Venn diagram. When we're reading this, let's highlight numbers just so we kind of know what's going on. It says in a survey of 400 people. Perfect. That's like my universal set. Like that's everyone. So when I look at my Venn diagram, all the numbers added up should equal 400. This is everyone in Venn diagram. Everyone in VD for Venn diagram. It was found that 285 enjoy pizza. 285 enjoy pizza means that when you add everything together in the Venn diagram, for circle P should be 285. No more, no less. And 320 enjoy muffins. Same idea. 320 in circle M. Then they give us one more little tidbit of information. It says, as well, 63 people do not enjoy pizza or muffins. 63 do not enjoy pizza or muffins. If we think about where that would be in a Venn diagram, that would be outside of the circles. So there's 63 in no circle. Circles. Should be an S on there. So there's 63 people that are in neither circle, they're in no circles. Fantastic. Okay, let's build this Venn diagram. When we're building our Venn diagram, we always want to start in the middle. Okay, that is key. The reason we want to start from the middle is because we have overlap here, and I don't want to accidentally count these people who like both with these people who like only pizza, or these people who like only muffins. So the goal for Venn diagrams is always start in the center. The way we start in the center is by figuring out how many people we've overcounted by when they gave us just that raw data. So for instance, if you took those numbers, they had 285 in pizza, plus 320 like muffins, plus 63 like neither, and you added those numbers together, you would end up getting 668. I think. Yes? No. Yeah. I feel confident in that. Okay, good. Thank you. That's just adding up the numbers, right? Saying this many people like pizza, this many people like muffins, this many people don't belong in anything. That's a lot of people. In fact, that's way too many people. What did we learn right at the very beginning about how many people should be in our Venn diagram? It should only be 400. Yet somehow, when I add everything together, I get 668. The reason why is because you've double counted some people in the survey. There is a number of people who like muffins and like pizza. So they would belong to both groups. That's the overlap. It's the extra people you've counted. If we do a quick calculation, 668 minus the 400 people that should be in there, we overcounted by 268. Right? We overcounted 268 people. That is your middle number. That's where you want to start.